Dear learners, today we are going to discuss the topic basics of machine learning. This topic is part of in fact the course Smart Technology, Hardware and Software MIO 002. The basic layout of today's talk is we will discuss the introduction of machine learning. What are the example of machine learning problems? We will discuss few of the machine learning examples, examples. What are the applications of machine learning? Though it is used for every field, but we will discuss few of the applications. Thereafter we will discuss the categories of machine learnings like supervised, unsupervised, reinforced learning, and we will discuss what are the machine learning algorithms, and will try to discuss at least one of the algorithm in detail with example. So if we see the introduction of machine learning, then it is quite popular since last few years. In fact, it is a branch of artificial intelligence and computer science that focuses on the use of data and algorithms, in fact, to imitate the way that human learns. And this learning means its performance improves gradually. More the learning, more the performance, or better the performance should be there. Sometimes people get confused that machine learning algorithms and classical programming both are same, but it is not the same. Classical programming is different and machine learning is totally different. Machine learning is based on in fact the biological learning, how we human being learn. So in classical programming we can understand this with the help of one example. Say we have a function, and in that function we give some input, we provide some input to the function and we get some output. That is machine learning, that is a classical programming. However, in machine learning we try to model or we try to figure out the function itself such that the input and the outputs are given and we are trying to find out the function. The technical definition, if we see the technical definition of machine learning, which is a standard and well known definition in fact. So a computer program is said to learn from experience, say E, with respect to some class of task T and performance measure P, if its performance at task in T as measured by P improves with experience. So here in this definition we have used three terminologies. What is the task to be learned? What is the experience or environment in which the learning is to be performed, or the training samples what we have, and how we can measure the performance after learning. So these three things are necessary. So after learning, if we perform the same type of task, then its performance as measured by the same parameter P should improve. Then we say that it is learning. Let me see few of the learning problems. How we can define a learning problem, machine learning problems. So as we have discussed that learning means improving with experience at some task. So we require three things to define the learning problems or any problem which we are going to solve with the help of machine learning. What is the problem? What is the task to be learned? What are the performance measuring parameters? Whether we are going to use, say for example, accuracy, precision, recall, F1 measure, these are few of the performance measuring parameter. And what is the training sample or environment in which the learning is to be performed. Let me take very simple example, say for example handwriting recognition learning problem. Here the task is to recognize the handwritten words or characters. So what is performance measuring parameters? What performance measuring parameter we can use for this? We can say that accuracy. or the percentage of words which are correctly classified. For example, if we have 100 words, 100 alphabets which are going to be classified after training, and out of these 100, if 95 words or characters are classified accurately, then we can say that its performance is 95%. And what is the training sample for this one? Obviously, we should have a database of handwritten words or characters with given classifications. Here the given classification means what exactly that particular word is. So that should be known in advance, that is the data should be labeled. Another example is, say, learning to play checkers game. So here the task is to play the checkers game, that is the task, that is the problem to be learned. And performance measuring parameter, we can use the percentage of game won in a tournament, that may be one of the performance measuring parameter. And training sample or environment in which the learning is to be performed is the opportunity to play against itself or against an expert. So we have well defined set of rules and all. With the help of that, we can train the program to play against itself or against an expert player. That may be the environment in which the learning should take place. Another example, we can take that robot driving learning problem. This is another very interesting example of machine learning problems. So here the task is driving on public 4-lane highways, say, using vision sensors by the robot. So it is not human driver which is going to drive, it's a robot or program which is going to drive the vehicle. That is the task to be learned. So performance measuring parameter, what we can use in this case? Let average distance traveled before an error occurs. That is one of the performance measuring parameter. Or we can say the amount of time till an error occurs. That may be another performance measuring parameter. So there may be more than one performance measuring parameters which can be used to measure the performance of the learning problems. Training examples, training experience in this case may be a sequence of images and steering commands which are recorded while observing a human driver. So that may be used for the training purpose. So obviously we will use some algorithm also which will use the training samples and will train the program, and thereafter we can use the performance measuring parameters to measure the performance. Before we come to the algorithm of the machine learning, let me see few of the applications where machine learning can be applied. Though as I told you that nowadays no area is left where machine learning cannot be used. Whether it is engineering field, whether it is medical field, whether it is agriculture field, or any you can think of financial field, everywhere there is used machine learning. Few of the applications of machine learning are listed here in these slides, in fact, like image and object recognition. This is one of the very popular machine learning application which recognizes image and objects in real time. So this object and image recognition can be used for, say, facial recognition, identifying any kind of object present in a photo or image or in a video. And in self-driving cars, this object recognition can be used to identify the pedestrians or any other vehicle or traffic signals and all. Another popular application is natural language processing. So here the machine learning is used at very large scale. In using the NLP, it is helpful to extract the meaningful information from the given text. For example, text summarization, there we use machine learning algorithms to summarize the text. So this NLP includes applications like sentiment analysis. We can use it for the speech recognition. We can use it for chatbots like ChatGPT nowadays is quite popular. So what kind of algorithm, what kind of technique it is using? It is in fact using the machine learning and AI techniques to train the model, and we see the performance of ChatGPT, how well it gives the output with respect to given query by the user. Fraud detection, it is also used in fraud detection to identify and prevent fraudulent transactions, which may include credit card fraud detections, bank fraud detections, insurance fraud detection, or any other kind of fraud detection. We can use the machine learning algorithms. Recommender system, very popular example. So it is used to suggest products or services to the users. For example, when we go for any commercial website, so we get some suggestions automatically, we get some kind of suggestions. So on what basis these suggestions are being produced? This is based on the machine learning algorithm. It is machine learning algorithms which are working in background which produce these products. So the recommender systems includes applications like movie or music recommendations on streaming platform, product recommendations on e-commerce platforms, and personalized news feed recommendations. Similarly, in healthcare, we can use machine learning at a large scale to analyze medical data, to diagnose diseases and predict patient outcomes. So a huge application is there in the healthcare domain. Autonomous system, it is used in autonomous system like self-driving cars, drones, robots, to enable them to make decisions and navigate through environment automatically. So this is popular through machine learning techniques in fact. Financial forecasting, we can use the machine learning for this purpose. Gaming is very popular area. So game industry is nowadays billions of amount is being generated from the games which are based on basically the machine learning techniques. So these are few of the machine learning applications we have seen, though here very limited applications we have discussed, but there are huge number of such kind of applications which one can think of. Next, we come to the categories of machine learning, how the learning is being performed, what are the various categories of it. So there are basically three categories of machine learning. One category of machine learning algorithms are in fact supervised learning, which is also known as classification. In the supervised learning, the training data or the observations or training samples are accompanied by labels indicating the class of the observation. In fact, in such kind of training data, we have a label, one of the attribute which indicates what is the output of that training sample, and new data is classified based on this training data. Unsupervised learning, which is also known as clustering. So the class level of training data is unknown in case of unsupervised learning. So in this one, given a set of measurements or training samples or observations with the aim of establishing the existence of classes or cluster in the data. So we have set of data which we try to group into different clusters based on the similarity measures through clustering or unsupervised learning algorithms. The third category of machine learning is reinforced learning. Reinforced learning works on the principle of in fact reward and punishment. That is, it builds its prediction made by gaining feedback from the random trial and error and leveraging insight from previous iterations. So in this one, we do not know what should be the exact output, but a kind of critic information in the form of feedback is provided, and that feedback helps to improve the learning process. Application of reinforced learning includes self-driving cars, industrial application where the model can learn to perform complicated tasks and optimize the process. So, under the supervised learning, there are various number of algorithms which are being used, and these algorithms are used for, in fact, the classification of the task, classification of the samples. So, few of the popular algorithms are enlisted here, like naive Bayes and Bayesian belief network is there. Decision tree based methods are there which can be used for classification problem. Memory based methods are there like k nearest neighborhood technique. SVM is there, support vector machine, which can be used for classification. We have large number of neural network models which one can use like perceptron, extras. Deep learning one can use for classification problem or rule based techniques. So these are few of the popular classification algorithms which works for supervised learning. Then we have clustering techniques which comes under unsupervised learning. So under the clustering techniques, the popular algorithms are k-means clustering algorithm. We have k-mudoid, which is also known as partitioning around mudoid algorithm. We have hierarchical clustering methods which one can use. We have density based spatial clustering of applications with noise, that is known as DB-scan, which can be used for clustering problems. So these are few of the popular algorithms which one can use. Now I want to cover at least one of the algorithm to make it clear how the classification, say supervised learning, is being performed. And the very popular method is, say, naive Bayes. In the naive Bayes method, we classify the unknown samples, unknown record, with the help of computing the posterior probability with respect to the class. As it is a supervised learning problem, so we know for the training sample we know what is the label, what should be the output, that is known. So if we have been given an hypothesis for which the attribute values are being given, so how we can compute its output? So as I told that it is based on a posterior probability which is defined as probability of the sample tuple, say x, with respect to class level C, that is PC over x is probability of training sample tuple x such that the class level is C. So if it is, for example, if it is a binary class problem, then its class will maybe say 0 or 1, or it may be yes or no. And the idea of this Bayesian classification is that assign to sample x the class label C such that the posterior probability is maximal. For example, if it is a binary class problem and there are two classes, say yes and no, if the posterior probability with respect to S is more, then that particular sample X will be assigned the class label S. But if the posterior probability with respect to no is more, then that class label will be assigned no. And the basic formula for this Bayes theorem is given here. The posterior probability is given by the multiplication between the conditional probability, that is Px by C, into prior probability Pc, and divided by Px. So here, as I told, Pc over x is called the posterior probability, Pc is called the prior probability, and Px by C is the conditional probability that a given hypothesis the tuple satisfied it. Px is the probability of the occurrence of data value x and is constant for all classes. Because Px is constant for all the classes, so we can say that the posterior probability is directly proportional to the conditional probability, and the prior probability. Let me take one example of playing tennis. Let we have these training samples. Here in this one we have 14 training samples. In this training samples, the last column is label, class. So here it is a binary class problem, so we have positive and negative class, and first 4 columns represents the attribute. Outlook, temperature, humidity and windy are 4 attributes. So we can see that in this example each of the attribute may consist multiple values, like outlook may contain sunny, overcast, rain. Similarly, temperature may contain hot, mild, cold. Humidity may contain high or normal. So if this training samples are being given, then how we can use this Naive-Bayes theorem to classify an unknown sample? So what we do some calculations, like we compute the prior probability of the class level. Here there are 2 classes, positive and negative. So we compute the probability of positive class. So out of 14 training samples, 9 belongs to positive class. So that's why it's a prior probability is 9 by 14 positive class, and similarly P of n, that is prior probability of negative class, that is 5 by 14, because there are 5 samples with negative class level. Then we compute the classic conditional probability with respect to each of the attribute, outlook, temperature, humidity and windy, with respect to its possible values. Like in outlook we have 3 value possible: sunny, overcast, rain. So we compute its conditional probability with respect to positive class label and with respect to the negative class label. Here in this table all these values are being shown. Similarly we do it for temperature. So these are all initial calculations in Naive-Bayes which we are required to do. So once we have done the calculation, thereafter we can use these values to predict the class level of unknown sample. For example, in this one, if the unknown sample X is rain, hot, high and false, that is the outlook is rain, temperature is hot, humidity is high and wind is false. So we can compute the posterior probability of this sample X with respect to the positive class level by using the formula, and with respect to the negative class level by using the formula which we have seen in previous slides. So we can see that the posterior probability with respect to the negative class level is higher, that is 0.018286, which is higher than 0.010582. So higher the posterior probability, we assign that particular class to the sample. So here the sample X is classified in class N, negative, that is one should not go for play. So this is the example when we have categorical attribute values, like outlook, temperature, humidity, windy, all these are categorical attributes. But if we have continuous attribute value, like in this example we can see that taxable income is continuous value. It may have infinite number of possible values. So how we can calculate, how we can use this Naive-Bayes theorem for such kind of problems? Like if the unseen sample is, say, refund is no, marital status is divorced and income is 120k. So here in this one income is continuous value. So we can compute the conditional probability and prior probability for the class level as well as the attribute value refund and marital status, because it is a categorical attribute. But what about the continuous attribute value income? So for calculating this attribute for continuous attribute values, one method is that we can use either discretization method, that is we can arrange the continuous value in the form of range into bins, and we can replace the continuous value with the bin value, or we can use probability density estimation functions. Like we assume that, say, attribute follows a normal distribution function or Gaussian distribution or Gauss or Laplace Gauss distribution. So accordingly we can use the probability density estimation function to measure the probability. And once we computed the probability, thereafter we can use the Naive formula to compute the posterior probability. Like if it follows a normal distribution, then we can use this formula, say the conditional probability Px over Yj, xi over Yj is been given by 1 by under root 2 pi sigma ij square into e to power minus xi mu ij whole square divided by 2 sigma square ij. So here in this one, in fact, the sigma is sample variance, which we can compute using the variance formula, and mu ij is mean value. So we compute this sample variance with respect to the class labels, different class labels. Like in this one, there are two class labels, no and s. So we compute the sample mean with respect to the no class label, and we compute the sample mean with respect to the s class label, and similarly we compute the sample variance with respect to no and with respect to the yes. And then we put these values in the formula and we compute the posterior probability of continuous attribute values. Like here in this one, if income is 120 and the class level is no, then we can put these values and we get the conditional probability 0.0072. Similarly, we do it for income 120 with respect to the class level yes. Okay. So once we computed these values, then we can use the Naive theorem, like here it is shown. We can put the values and can compute the posterior probability. So higher the posterior probability, like in this case with respect to class level no, its posterior probability comes out to be 0.0006, and with respect to class level s, it comes to 4 into 10 to power minus 20. So since this with respect to no class level it is higher, so we can assign the class level for this test record x as no. The beauty of this Naive classifier is that even we can make the decision based on the partial information about attributes. That means even if we do not know all the attribute values, then also we can compute its posterior probability. For example, if we know only that marital status is known, then how we can use? We can use the prior probability with respect to class level s and no, and we can put the conditional probability of divorce in the formula, and then we can compute the posterior probability, and accordingly we can define its class level. But what are the issues with Naive classifier? Let me discuss few the issues which are there. In Naive classifier, as we know that this posterior probability is in fact the product of two components, prior probability and conditional probability. So if any of the value is 0, then entire term will be 0, or sometimes it may happen that both with respect to all the class level the posterior probability comes out to be 0. Like in this one, if we delete this training samples say 7, and then we compute the numerical values of posterior probability of all attribute values, then we get, say, with respect to this posterior conditional probability P refund is equal to S, such that class level is yes is 0. Similarly, P marital status is divorce, such that class level no is 0. So when we use this for, say, given unseen sample is refund is equal to F and divorce is the marital status, and income is, say, taxable income is 120k, then for both the class levels the posterior probability comes out to be 0. Then how we can decide what should be the class level? So there will be tie in this case. So this is problem in fact. So to overcome these problems, so we can use in fact for computing the conditional probability, we can use some other method like Laplace estimate method we can use, or M estimate methods we can use, so that this 0 value problem can be avoided. So let me summarize what we discussed in today's lectures. We have discussed in fact let me summarize the Naive Bayes theorem first. So this Naive Bayes in fact is robust to isolated noise points. It handles the missing values by ignoring the instance during probability estimate calculations. It is very robust to irrelevant attributes. It is redundant and correlated attribute will violate class conditional assumptions. So there are some modified form of this naive Bayes theorem like Bayesian belief network is there, which can be used for sort out this kind of problems. So in today's lecture we have discussed in fact what is machine learning, what are the applications of the machine learning, what are the categories of machine learning, and we have discussed the classification clustering algorithms, and we have seen how the naive Bayes classification algorithm can be used to solve an example. Thank you.